Assalamualaikum warahmatullahi wabarakatuh and have a great day. I would like to share the analysis of the movement of two cores which collide, and after the collision they start as one big mass and shared velocity. During this activity, students can immediately discover the momentum and kinetic energy graph which they desire. It will appear at the right side of the screen in the tracker application. So now I will analyze the total momentum before and after the collision, and also the total kinetic energy of the system, and also the impulsive force during the collision. This is the graph of momentum when we compare the red and the blue core in one graph. So in the table, I'll choose momentum and value of kinetic energy for both red and blue core. Before the collision, let's say at t equal to 0.1, okay, we can read the reading from the graph and also from the table. The table is more precise, which it shows until 3 decimal points. So at t equal to 0.103, so 0.103, the momentum of the red car is 0.086, while the momentum of the blue car is 0.247. After the collision, let's say we take this reading, red, so the total momentum before collision is equal to 0.333, whereas for the total momentum after collision is 308. So the percentage error is 3.900%. Next, we will compare the kinetic energy before and after the collision. So I will change this graph to kinetic energy. So we have kinetic energy here at t equal to 0.103. So the total kinetic energy is 0.182, and after the collision, the total kinetic energy is 0.132. So by theory, total energy of the system is not conserved, right? This is by theory. So we can see here that the kinetic energy after the collision is lower than the kinetic energy before the collision. In an elastic collision, kinetic energy is not conserved due to the action of internal friction. Some of the kinetic energy turn to vibrational energy of the atom, causing heating effect, and the bodies are deformed. Alright, now we continue to impulsive force. To determine the impulsive force of both cars during the collision, students need to know the time interval before and after the collision. So the time interval is the time just before the collision and after the collision. Alright, now impulsive force is equal to rate of change of momentum. So change in momentum equal to mv minus mu over delta t. So delta t or time interval is from t equal to 0.14, and right after the collision, when the both cars stick together, it is 0.21. So delta t will be 0.069. So the answer will be 0.193 Newton. And for the blue car, equal to 1.029 Newton. So this is the impulsive force for the red car, and this is the impulsive force for the blue car. A slightly difference there. Now we want to find the percentage error for the impulsive force for the both car. So the answer will be 3.016% of error. So that's all for now. As a conclusion, by using tracker application, experimenting the principle of conservation of momentum becomes more student-friendly when they are using any gadget such as smartphone or any objects to perform the experiment. So we had determined the total momentum for the inelastic collision before and after collision, and we proved that the total momentum is conserved with percentage error of 3.9%, and the total kinetic of the system is not conserved, which the kinetic energy before the collision is higher than the kinetic energy after the collision due to the action of internal friction, which the kinetic energy turned to vibrational energy of the atom. And lastly, we had determined the impulsive force for both cars during the collision. So from the calculation, the red car registered 1.093 Newton, and for the blue car it is 1.029 Newton, and the percentage error between the blue and red car is 3.016%. So that's all for now. Thank you for being with me, and see you next time. Assalamualaikum.